Hello class, this video is going to cover section 4.4, which is common logs, natural logs, and change of base formula. So to start out with, just need to make sure that we can all use our calculator to find logs and natural logs. And it doesn't matter which calculator you're using, if it's a calculator on your phone, calculator, just a regular handheld calculator, a calculator you found online, or one on your computer. Most all calculators will do just a common log, base 10, and also our natural log. So for this calculator I have, it's on my computer. If I wanted to do the log of 1,000, I would actually have to put in 1,000 and then press log, and I'd end up with 3. So the log of 1,000 is 3, which makes sense because it's log base 10. 10 cubed is 1,000. If I want to do the natural log of 142, very similar. I just type in 142 and then press the natural log button, and I'd end up with 4.95 approximately. If I want to do the natural log of e cubed, first thing I'd have to do is e, which is a constant, 2.71. E is similar to pi, where it's just some number, 3.14 is pi. E is 2.71. So I want to do e cubed, so I press my cubed button, but then I want the natural log of that, which ends up being 3. So the natural log of e cubed is 3. So depending on which calculator you're using, you might need to put the number in and then perform the operation. Okay, so two types we're going to talk about are common logs. So if it's not written, this is base 10. So if you ever see it just written as log x, it is a base of 10. A natural log is simply a log of base e. Getting back to our problem where a natural log of e cubed, recall our properties of logs hold true still for natural logs. We can bring the 3 down. So this is 3 times the natural log of e. Well, natural log of e is the same thing as saying log base e of e. If I'm doing log base e of e, that's just 1, because e to the first equals e. So it's 3 times 1. That's why I end up with just 3 for a final answer. We can get into some applications when dealing with common logs. So in chemistry, the pH of a solution is defined as this formula. So it's not a formula you need to memorize or be able to derive. This would be given to you in the problem. So the pH of a solution is negative of the natural log of whatever the concentration is. So that H sub 3, 0 plus is the concentration. So to find the pH of a solution with this given concentration, it's simply going to be negative of the log, if you want to think of it as negative 1 times the log of all of this. 2.5 times 10 to the negative 4th. We can punch that into our calculator, and our pH is approximately 3.6. So that'd be one. You just put it right in your calculator and it'll give you the answer. Now, if we wanted to find the concentration, because remember, this piece right here, this is representing the concentration of a solution with pH 7.1. So now we have more of an algebra problem where we have an unknown that we need to solve for. So 7.1 is negative 1 times the log of our concentration, H sub 3, 0 plus. I'm going to divide all of this by negative 1 to get that out of there. So it's a negative 7.1 equals the log H sub 3, 0 plus. Now to solve, really this is base 10, even though it wasn't written, it's a common log. I want to write this in exponential form. So now it's my base raised to a negative 7.1 equals my concentration. That's a number I can put in my calculator. 10 raised to the negative 7.1 ends up being approximately 7.9 times 10 to the negative 8th. So we can still solve for an unknown that we're taking the log of by using our exponential properties. Change of base property. So most calculators, you can do log, just a common log. It has that functionality on there, your cell phone. Easily find those online. Well, it now will say we want to take the log base 7. Well, those ones might not be as easily to find. You need to go to one that has, we need to find one with that log base 10 function right on there. So change of base tells us, doesn't matter what the base is, we can change it by writing it as a quotient. All right, so let's use the change of base to evaluate log base 5 of 17. So I'm going to change this to log base 10. That's what my change of base formula lets me do. The 17 goes on top. Log base 10 of 5 goes on the bottom. Okay, so it kind of gives you a hint how it's written. 17 is on top. 5 is our base. We're going to bring that down to the bottom. So when I work this one out, if I do log base 10 of 17 and then log base 10 of 5, work that all out, becomes 1.76. So my calculator will do that for me. 4.4 homework is in Math Excel, due Sunday 3/22 by midnight. Check back in. I'll have a folder up for next week as well with a few lessons in there and a few assignments to do to keep us moving forward. Take care.